India is about to spend 9,200 kilograms of spacecraft and roughly 2,100 crore rupees, about $250 million, to bring home just 3 kilograms of dirt. That's not a typo. That's the actual math behind Chandrayaan-4, India's most ambitious moon mission yet. And here's the part that should stop you. The spacecraft ISRO built to pull this off is too heavy for the country's own most powerful rocket. So instead of launching once, they're launching twice and assembling the mission in space. Not once, but twice, with zero chance of a rescue if either assembly fails. On paper, that sounds like a compromise. In reality, it's the only way anyone on Earth has figured out how to do this without the one rocket India doesn't have yet. By the end of this video, you'll understand exactly why, and why the harder path might be the smartest move ISRO has ever made. Here's the actual spacecraft, and it's not one machine, it's 5. A propulsion module, a transfer module, a lander, an ascender, and a re-entry capsule, built to separate from each other, one at a time, on the way to the moon and back. ISRO packs those 5 modules into 2 stacks. Stack 1 is the landing half, lander plus ascender. Stack 2 is the ferry half, transfer, re-entry, and propulsion. Each stack weighs around 4,600 kilograms. Combined, that's 9,200 kilograms. Do the math. And 99.97% of that mass exists purely to protect and deliver the other 0.03%. The 3 kilograms of moon dust this whole mission is actually for. India's LVM-3, the country's biggest rocket, can only lift about 4,200 kilograms to the orbit this mission needs. Not enough for one stack, nowhere close to both. It's like moving a queen-size bed into a tiny apartment. The frame won't fit through the door hole, so you carry the frame in, then the mattress, and build the bed once you're inside. That's Chandrayaan-4's entire flight plan, except inside is Earth orbit, and getting the 2 halves to meet up requires something India has only pulled off once before, ever. Compare that to China. When China brought moon samples home with Chang'e-5 and Chang'e-6, it used one rocket, the Long March 5, and launched the entire 8-ton spacecraft in a single shot. No splitting, no assembly required in space. India doesn't have a rocket like that, not yet. The next generation launcher that could carry this whole mission in one piece is still years away from its first flight. So instead of waiting, ISRO is doing it the hard way right now with the rocket it actually has. 2 launches instead of 1 isn't a failure. It's the price of moving first instead of waiting for the perfect tool to show up. But here's what most coverage of this mission isn't telling you. The rocket this entire plan depends on doesn't fully exist yet either. To lift these stacks at all, ISRO has to swap the LVM-3's engine for a brand new one, the SE-2000, built to produce 2.5 times more thrust than the engine it's replacing. At its most recent hot fire test, in June 2026, that engine reached 88% of its full rated power. And ISRO's own public timeline says the upgraded rocket won't be flight ready until 2028 or 2029. The mission is currently targeting 2027. Read that again. The rocket isn't scheduled to be ready until after the mission is supposed to fly. That's not speculation. That's sitting inside ISRO's own reports. Even once both halves are built and launched, they still have to find each other in space twice and dock, closing the distance at over 28,800 kilometers an hour. That's roughly 10 times the speed of a rifle bullet. 2 spacecraft, hundreds of thousands of kilometers from home, have to meet nose to nose instead of colliding. India has done this exactly once before, in January 2025, becoming only the 4th country ever to pull off autonomous docking in space. Even that first rehearsal had to be delayed after a risky failure scenario turned up in simulation. Chandrayaan-4 needs this same maneuver to work twice, once to assemble the spacecraft near Earth, and once again in lunar orbit to hand off the sample. If that second docking fails near the moon, there is no backup rocket and no rescue mission. The sample and the mission is just gone. This isn't ISRO's first attempt at something this hard. In 2019, Chandrayaan-2's lander crashed into the moon after a software error in the final seconds of descent. 4 years later, Chandrayaan-3 fixed that and landed successfully near the South Pole, the first country ever to land there. But there's a detail most people missed. After Chandrayaan-3's main mission was done, ISRO quietly flew the leftover propulsion module from lunar orbit back to Earth orbit as a bonus experiment. Nobody called it training at the time. Looking back, space analysts now believe it was almost certainly a dry run for the exact return trip maneuver Chandrayaan-4 needs for real. So why go through all of this for 3 kilograms of dirt? Because that dirt is coming from somewhere no human or robot has ever physically touched, permanently shadowed craters at the lunar South Pole that may hold water ice. And the docking, the robotics, and the re-entry technology being proven here aren't just for this one mission. India has already put a Bharatiya Antariksh Station, its own space station, on the calendar for 2035, and a crewed moon landing for 2040. Chandrayaan-4 is officially the stepping stone for both. Even this 2-launch workaround has an expiration date. India's next rocket, built to carry 3 times the payload, is already in development, designed specifically to make missions like this one unnecessary. Right now, India is choosing to solve an almost impossible problem with the tools it actually has, instead of waiting years for the ones it wishes it had. 2 rockets, 2 dockings, at 10 times bullet speed, with no room for error. All to bring home 3 kilograms of moon. A country that can pull off a plan this complicated with no rescue option isn't just proving it can reach the moon. It's proving it's ready to stay there. In 2027, we find out if it works. If this kind of thing fascinates you, the trade-offs, the risks, the sheer audacity of pulling off something like this with the tools you actually have hit like. It helps this channel keep making videos like this one. And if you want to be here when Chandrayaan-4 actually launches, subscribe, because this story isn't over. It's just getting started.